Bienvenidos, Ushamdi, and welcome CTS-131 Section 875 students for the Spring 2018 semester at Anne Arundel Community College. This is the Cisco Networking Academy Routing and Switching Essentials version 6 course, and this morning's Packet Tracer tutorial and solution set is going to be on Packet Tracer Activity 5.3.1.2, where we now take all of the skills and the knowledge that we've acquired to the course at this point and we employ them to solve the issues in the skills integration challenge. So let's go ahead and take a look at the topology that we're going to be dealing with. As you can see, we should be familiar with this. We have a single Cisco switch and 2 PCs, and we're all in VLAN 1. So in other words, it's theoretically possible that this switch was pulled from the box, turned on, and the PCs were simply plugged in. Now, we also have a switched virtual interface, or a switch virtual interface, an SVI, which is a logical interface on the switch. In other words, it's done in software and it allows us to remotely manage and connect to the switch. So let's dive in here. We're the network administrator. We've been asked to configure the new switch, and here are the requirements. So let's go ahead and dive in on switch 1, and we're going to make this a little bit larger here so we can see what we're doing. All right, and now let's get on to the command line, and here we are in the command line. We can see it's a 2960 switch with 24 ports. We're running LAN base, so no multi-layer capabilities here. In other words, we can't be running OSPF and EIGRP. And it looks like we're running 12.2 code. All right, so we're in we're in user exec mode, as is evidenced by that greater than sign there, and you can see we have no hostname on the switch. So let's transition into privilege exec by issuing the enable command. Now, privilege exec is the mode in which we can now reach all of the global configuration mode and sub modes for the interfaces and routing protocols if this was a router. So this is where we're going to go ahead and launch all of our configuration work from. Now we're going to go ahead and configure switch 1 with the following initial settings. Well, we're going to put the host name on here first. So let's get into global config, and that's the configure terminal, or just conf t command, and we're going to issue the host name command. So it looks like the name is supposed to be switch 1, and we'll watch our completion percentage to make sure that we're on target here. So that should be the host name that they're looking for. Now they also want a banner. We should be very familiar with banners at this point. So remember, we're going to say banner MOTD, and now we need some delimiting character here. Now you could use the letter C, you could use the hash sign, there's all kinds of characters. I prefer the % sign because it's typically not very common that I have some sort of a banner message that has a % sign in it. So it just has to include the word warning. So we're going to do this. We're going to say warning. We're going to put it in all lowercase. We'll put it in all uppercase. And then maybe we'll throw in a mixed case in here. Warning. All right. And hopefully that's going to satisfy the requirement. Now remember, we ran into some peculiar behavior where if we had a space here and then we put the % sign, that we would not get a point. The scoring engine didn't like that. It would work, but the scoring engine didn't like it. So I'm going to keep everything together here on this line with no spacing between the delimiting character and the actual banner that we're configuring. And it looks like that worked, and we ended up with our point. So console port login and password Cisco. Well, let's go ahead and see what's currently configured by saying do show run. Remember, the do is required because we're in global configuration mode. And so this is going to go ahead and run the show run command. And so right now the console line, as you can see here, it's just simply line console, right, with no settings whatsoever. So we're going to get into line con 0, the single console port that is on the switch, and we're going to go ahead and indicate that you do need to log in here, and take a look at that. We must first set the password. So let's go ahead and say password Cisco, and I'll hit enter, and we should see, oh, we got 3 points for that. And now we want to say login. And so the password on Packet Tracer must come before you say login or issue that login command. All right, now encrypted enable password of class. So remember, If I'm setting the enable command, it wants it to be encrypted. So I'm going to say enable secret as opposed to enable password. Remember, enable password is very, very weak. So we want enable secret. And in fact, remember that the best practice, and let's pull up, and this is worth mentioning because MD5, which is what is being used for MD5, which is what is being used for the hash when you do the enable secret, is definitely not a strong choice. So what I would say is I would say enable, and then I would choose algorithm type, right? Algorithm type, and you want to go with script. This is considered to be the most secure approach, and then secret, and then whatever the password would be. Cisco, right? So enable algorithm type script secret Cisco. Again, this is the real world scenario, and this is what you would do in the real world. In our packet tracer activity, we just need to make sure that it gets set up properly. So we're going to say enable secret, and then the password is class here. So we say enable secret class. All right, we're going to encrypt plain text passwords. Remember, this is a service that the router is providing, right? It's encrypting these passwords. So it's service password encryption. And that's going to take all of the unencrypted passwords. In fact, let's say do show run and look at our console line where we just configured a password. And you can see that if someone's looking over my shoulder, they can clearly see and very easily remember that that's going to be the password. However, when I do the following and I say service password encryption, then hit enter, and now say do show run, let's go to the bottom of the file and let's see what that password looks like now. So certainly not impossible for a shoulder surfer to look at this and maybe get a few of the characters memorized, but much more difficult than simply seeing the word Cisco in all lowercase. Now, again, to be clear, Cisco has said multiple times that the Type 7 password is not there to keep out the wiliest of hackers. The Type 7 passwords are there to prevent the shoulder surfers. In other words, those bad actors who might work where you work that are walking by while you're doing something in your terminal on a switch or a router or whatever the case may be, and who can then see what you have the password set to. So again, that's a little more difficult to remember than simply lowercase or all lowercase Cisco. All right, so we've encrypted our plain text passwords. The management interface addressing, right? Now, what do they mean by the management interface addressing? Well, let's say do show IP interface brief and see which interfaces are actually configured here. And when we look, we can see fast Ethernet 01 and 02, and those are, we can assume those go to PC1 and PC2 because this is similar to an activity that we've done before. Now we see VLAN 1. Right? So remember, this is the remote management interface. It's a virtual interface. This is all being done in software. There is no physical port on the front of the switch labeled VLAN 1 management interface. In fact, every port that is in VLAN 1 will have the ability to connect to the switch remotely when we configure this IP address. So when they're saying management interface addressing, they're talking about interface VLAN 1. And so we need to go ahead and we need to put on here IP address 10.10.10.2. Let's make sure we've got that right. And it's a /24 where the first 24 bits, meaning those 8 bits, these 8 bits, and these 8 bits, so 3 times 8 gives us 24. And then we're going to say no shut. And I could even put a description on here, always a good idea, to simply say remote management interface. Put my initials here and then say 03/03/2018. So if somebody were to come along after me and see that VLAN 1's switch virtual interface had been configured, they could come ask me and say, hey, I noticed that you configured this. I was just curious. Why are we doing it this way? Why don't we do it that way? Right? So always a good idea to document the things that you're doing. All right, so the management interface addressing has been taken care of. Now, a great question came up earlier this week on a supplemental activity. I think it's 5227 that we're going to be taking a look at. And if I say do show IP interface brief, we can see that we've got the VLAN 1 switch virtual interface here with an IP address and that the interface is up. Now, the question was, when would you see a switch virtual interface down, right? And remember, that comes up when the SVI may be configured, but we have no interfaces in that VLAN that are active. So here's what I mean by that. If I was to say interface VLAN 99 and say IP address 10.99.99.2, and we'll make it a /24 as well. And then I said no shut, and then I say do show run. Oh, sorry, not do show run, do show IP interface brief. Take a look at VLAN 99. You'll notice that it didn't magically pop up. And that's because, one, we have no VLAN configured for that. So even if I was to say VLAN 99, right, and you can say the interface VLAN 99 change state to up, and then say name, management, do show IP interface brief, take a look. So it was down when the VLAN wasn't created. And now it is up down. And the reason it's up down is because it's up at what they consider layer 1 to be here when we're talking about SVIs, is the definition of the VLAN itself, the creation of the VLAN. So do show VLAN brief, and you can see that is where we have the VLAN created, and the status is active. However, the SVI do show IP interface brief. The SVI is up and then down at layer 2. And the reason it's down at layer 2 is because there is no port that is active on the switch in VLAN 99. Now, VLAN 1 is much different. Remember, with VLAN 1, all of the ports by default are in VLAN 1, and we have 2 ports that are plugged in that are up, that are active. Therefore, we're going to see that VLAN 1 would be up. All right, so that takes care of our management interface addressing, and that was a great question by Lauren this week regarding the behavior of the SVI and why it shows down, and then up, down, and what the differences are. All right, so now we're going to configure SSH to secure remote access with the following settings. So let's get out of our VLAN configuration mode here. All right, we're going to set our domain name. So remember, before you generate the crypto keys, you can set the domain name. Now remember, the reason I'm saying can is because there's a misconception that you have to set the domain name in order to be able to run the command crypto key generate RSA, and I think they want the return here. Yeah. And you can see we get this error. It says, please define a domain name first, because it's used as part of the naming in the keys. If I was to pull up a real Cisco switch here, and we'll pull this command back with a Control U, if I was to say crypto key generate RSA modulus 1024 and hit enter, you'll notice it says, please define a host name. So let's take care of the host name first. I forgot about that. I was focused in on the crypto key generate. You can see it says, please define a domain name first. But what if I say crypto key generate RSA, and I'm trying to remember where it's at, because usually label, there it is, and it says provide a label, right? So I'll say label and then simply make it a word. So R1, we'll just say R1 SSH-key. And then we go on with our command, modulus 1024. Aha! So you can see the name for the keys is what is being looked for there. So if you don't label the name of the keys, then you will need to configure the domain name. However, if you use a label, you don't have to have the domain name configured. I just want to make sure I cover that because there's a lot of confusion and a misconception that you have to have the domain name configured to generate the crypto keys, and you don't. You can label the crypto keys, and that will achieve the same goal. So here we are. Let's go ahead and say IP domain name, and the domain name is going to be cisco.com. Now it says we need an RSA key pair parameters to support SSH version 2. Now, the minimum key length for SSH version 2, I believe, is 768. Because if I were to say 512, and actually I think it says it right in here, the size of the modulus range, choosing a key greater than may take a few minutes. Well, it doesn't. Let's see what it says here. Yeah, that's not what we wanted, and we shouldn't get the points for that. Because to support SSH version 2, in fact, if we come back over here, and let's see, IPSSH version 2, if I was to then rerun the crypto key generate and say 512, aha, we see something interesting here. It says the keys are going to be replaced. Warning, SSH version 1 is vulnerable. We're not supporting it. Please move to SSH version 2. But then here's the syslog message we're looking for. All right, so SSH version 2 has been disabled because the RSA key needs to be at least 768 bits for SSH version 2. So remember that. And take a look. It even downgraded us after it disabled it to SSH 1.5. And we definitely do not want to be at version 1.5. So remember that. 768 bits is the minimum to support that. But we're going to go ahead and say, we're going to replace those keys, and we'll say 1024, and hopefully we're going to see some points there. So IPSSH version 2 is going to be supported, so set the version of version 2. The user admin with secret password CCNA. So here we go, username admin, and now remember, it's not password, it's secret. And the secret password is going to be CCNA. And so you should see, and actually it looks like we bumped up about 10 points right there, maybe catching up from the SSH keys. All right, VTY lines only accept SSH connections and use local login for authentication. So let's go ahead and get into line VTY. I usually do 0 through 15. If we do a do show run, we can see the number of VTY lines. Now remember, these are virtual terminal lines. In other words, they're allowing multiple concurrent remote sessions for management or whatever the case may be, but they're allowing multiple concurrent sessions to connect to this switch. And so we're going to secure these lines by ensuring that the transport input is going to be SSH, and we're going to use the local AAA database. And AAA is something that we may come upon, but it's just for the authentication, the authorization, and the accounting. And they refer to it as the local AAA database because it's simply the running config, right? So we're logging in locally, which means we're not keeping our login information on some remote server, like maybe a Windows LDAP server of some kind, right? Or a remote radius server of some kind. It's all being done locally right here on this switch. So I say login local, and now when we look at our VTY lines, what do we see? We're going to have to locally log in, and that is why we created the user admin with the secret password of CCNA. Because now when someone tries to remotely log in, they're going to be prompted for both a username and a password. Here on the console line, are we going to see both a username and a password when we go to log in? And the answer is no, because it doesn't say login local, it simply says log in. So if I was to save my config right now and log out and hit enter, and you can see we're on the console line here. Switch 1 con is now available because I've logged off of it. But now when I come to log back in, we get our banner warning, the message of the day, and a password is all I'm being asked for. And that's the difference between login and login local. So pay very close attention to that. So now we're back in user exec mode. So enable gets me to privilege exec. Again, remember we set the enable secret to class. So now I'm back in privilege exec mode, and let's go ahead and continue on with our activity. Now, we're going to be configuring the port security feature to restrict network access. We want to disable all unused ports. So how do we see that? Well, from privilege exec, I don't need do, right? So I could say show IP interface brief. We have a 24 port switch. It looks like 3 to 24 are all down, including gig 01 and gig 02. So let's get into global config and let's use our interface range command, because this is a massive time saver here. So interface range fast Ethernet 03 to 24, gigabit Ethernet 01 to 2. And what are we going to do? We're simply going to shut these down. And typically what I do is I put a description on here and I'll say shut down by admin, do not use, and then I'll put in my initials and then a date. Whoops, 03032018. And that way, it's pretty obvious that when someone comes along, they can see why the port is shut down, who shut the port down, and when the port got shut down. Again, the descriptions aren't required, but it is definitely a best practice. All right, so we've disabled all unused ports. Now we're going to set the interface mode to access, so switch port mode access. And I'm curious here, it says port security to restrict now. So set the interface mode to access, and I'm wondering, I don't think fast Ethernet 01, yeah, 01 and 02 don't have that set. So let's go ahead and do that on interface range fast Ethernet 01 to 2. Now again, these are both in the same VLAN, so we can go ahead and do the configuration on both of these ports together, because VLAN 1 is the default, so we won't be issuing the switch port access VLAN command. So they're already in the same VLAN together, so we can configure them together with that interface range command. So we're going to set the mode to access, so switch port mode access, and I think this is where they wanted to see that command, not on the other ports, even though we're not going to end up losing points on the other ports. So switch port mode access, we're going to enable port security to allow only 2 hosts per port. Now remember, when I say switch port security, I have to issue this command by itself. If I was to say switch port security and set and do the MAC address sticky, the maximum to 2 and the violation to restrict, right? If those were the settings we were using, if I ran those commands, none of those settings would take place. You have to have this command by itself first before any of the other switch port security commands are going to take effect. So we say switch port security, and you can see we just bumped up to 88 there. Now we're going to enable, and I'm squinting here, enable port security to allow only 2 hosts per port. So switch port security, maximum, and what is the default? Quick pop quiz right here. Exactly, the default is to allow a single MAC address. And that's what we're referring to when we say maximum number of addresses. We're talking about the layer 2, the data link layer physical address, which is that 48-bit quantity known as the MAC address. So we say switch port security maximum, it's between 1 and 132, but we only need 2. So enable port security to allow only 2 hosts per port. Record the MAC address in the running config. Well, we know how to do that. It's going to be switch port security MAC address, and we can either hard code the MAC address or we can stick it to the port upon the first frame entering this switch port. Remember, that is how port security is working behind the scenes, right? So if you were to pull the curtain back to see how is the switch doing this, it is simply inspecting the frames at layer 2. Remember, the frame is the protocol data unit, the PDU, in that OSI 7-layer model. At the data link layer, the frame is the PDU in which you'll find the source and destination MAC addresses. And it's the source MAC address on the ingress of the frame, right? On the ingress, the frame entering the switch, it's the source MAC address field in the layer 2 frame that the switch looks at to say, hey, I'm going to stick you to this port, and it's on the first frame it receives on the ingress from the host that's connected. So we say switch port security MAC address sticky. You can see that we have already moved to 100 out of 100. However, we've got some work to do here. It says ensure that port violations disable ports. Well, in fact, we are at 100 out of 100. So it's interesting, right? Because you may be confused. Why did the completion scoring engine, or why did the scoring engine move our completion percentage to 100 out of 100 when we have a command left, which is ensure that port violations disable the port? So let me do that. I'll say switch port security, violation, and we have 3 modes, remember, and these are listed alphabetically, but conveniently they are also listed in order of severity with respect to the action being taken. So protect would simply drop the frames that are coming from the bad actor. Restrict will drop the frames coming from the bad actor and generate a log message that, hey, we have an issue here. And then shutdown being the most severe is it's going to error disable the port. So I'm going to say switch port security, violation, shutdown, and I'm going to hit enter. Now you'll notice the scoring engine didn't take points away. It can't add any points because we're already at 100. So when I say do show run, where is the switch port security violation shutdown command? So you may think to yourself, oh, I must have mistyped it, or there was an error and I just missed it. Let me enter the command again. Okay, no error. Do show run, and it's still not there. So you may be thinking, well, maybe there's a bug with Packet Tracer. No, remember, this isn't a bug. 99.9% of the time, Cisco, by default, if it is a default setting that is being applied, is not going to show you that setting in the running config. And so that's why we don't see that setting. So it's the same thing. If I said switch port security maximum 1, that is a default setting. And so therefore, we would not see that. In fact, if I went to fast Ethernet 0, let's go to 03. And if I was to say switch port security maximum 1, and let's see if it shows up, it doesn't show up on fast Ethernet 03 because 1 is the default. And again, remember, 99.9% of the time, if it's the default, you're not going to see it in the running config. So be aware of that. And it's also a call to action for you to make sure that you're very familiar with what the defaults are for each of the feature sets that we're working with. Because this is also something that when you move forward to take and you go to sit for the exam, whether it's the ICND1 or the ICND2 or the full CCNA, where the default settings do come into play. And they will play, right? The Cisco testers will play and check and test your knowledge as to whether or not you fully understand the default settings. Now, this is not something I've ever seen, so there's no NDA here, but let's think of a question that we could pose as testers that would call into effect the default setting. Maybe the question asks you, what is going to happen if there is a port security violation on fast Ethernet 01? And the answers may be, it's not going to do anything. It's going to restrict, or it would drop frames and issue a log message. It's going to drop frames and not issue a log message. I think we already said it's not going to do anything. And then they could give you some other bogus answer, but they never ever say it's going to shut the port down, because at that point, at this point right here, you would need to know that even though the command is not there in the configuration, that is actually what's going to happen, right? So again, just something to think about. Think about how the defaults could be used as questions that may call into action your understanding of what the defaults are for whatever the technology may be. All right. Well, that is going to wrap up our tutorial and solution set for Packet Tracer Activity 5.3 1.2, where we took a look at the skills integration challenge. We did some basic switch configuration, and then we went a little deeper into the SSH configuration as well as some port security. We talked about how to configure SSH, why you need the domain name, because it's being used as part of the name for the switch. In fact, I'm pretty sure that the command do show IP or do show, let's just get here, show SSH, show IP SSH, yeah, show IP SSH, and I want to make sure that I cover this real quickly here. Show IP SSH. Yeah, so obviously we get more information. It is show IP SSH, and a good command to have because you can see that that's what it's using for the name of your keys, this R1 SSH key, and that's where the domain name would come into play. All right, well, thank you guys so much for watching. Hope you enjoy your weekend, and I will see you in the next tutorial.